architecture, little endian, big endian, and then load store instruction for pipelining, and pipelining we have discussed. So the next topic which we need to discuss here is your application specific integrated circuit. Okay. So in application specific integrated circuit, as I told yesterday, the basics part. So it is nothing but a chip. Okay, it's nothing but a microchip, or we are going to call it by IC. So normally, normal terms which you are going to get, it is called as IC. So now, when you are going to have the IC, if you have so that particular IC is going to be designed to perform a specific or unique application. So you are going to have the IC. So that particular IC, you are going to build the application, and you are going to port that particular software or program to that particular microchip. Okay. So then, so this is basically used as replacement to conventional general purpose logic chips. Okay. So now, when you specify about application specific integrated circuit, so application specific integrated circuit normally functions integrates several functions into a single chip, and thereby reducing what? Thereby reducing the administrative cost. Since most of the functionalities will be uh, embedded, embedded, embedded into a single chip only. So you need not all the functionalities will be inside this single chip. So by that, it is going to reduce the development cost of the system. Okay. So most of the ASICs which you are going to have in today's world is of proprietary product. So it is going to have the proprietary product which you are going to have. So now, as a single chip, so your application specific integrated circuit is going to consume less space. Okay, so it's going to take less space, and thereby it will help the design of smaller systems with high capabilities and functionalities. So if you are going to build your own, if you want to start your new IC manufacturer, so when you want to develop the new IC manufacturer, so it will reduce the development cost if you are going with the ASIC. Okay. So now, what are the different? If you are going with so if I am going with the normal microchip manufacturer, so here, so special application, it will be fabricated. Okay, the special applications which will be there, it will be ASICs can be prefabricated for a special application. That means what? Whenever you are designing a application specific integrated circuit, so that fabrication means what? So you are build a chip after embedding the program into that particular chip. First, you are going to program the chip. After programming it, you are embed that particular application inside that particular chip. For example, is your BIOS is the example for your ASIC. It is also one of the typical example what we can give. So that is going to have the different drivers inside your BIOS. That is nothing but your basic input output system, which will be there inside your PC. Okay. So now that particular application will be fabricated by using the components from reusable building blocks library of components for a particular customer application. That means that particular program what you are going to do, that will be helpful to build, that will be useful for one particular application. So that will be useful for one particular application. So now when you are doing the fabrication, so fabrication is nothing but what? Building a die. Okay, so you are going to building a die or building a chip. Okay, what it is called by. So it requires a non-refundable initial investment. So okay, so non-initial investment means what? So when you are developing a first time, any work you want, anything you want to build for the first time, you will be having some losses, right? So you want to do the research, and to do that particular research, you have to invest the money on that one. So at that time, that is the first time investment which you're going to have till you find the product. Because when I want to find a new product, so I should have to incur some amount on that particular product. So that is what the non-refundable initial investment which you're going to have. So if you have to go with the research, all the research will be having one non-refundable initial investment. So here also, when you specify about the ASICs, that is application specific integrated circuits, here also it requires a non-refundable initial investment. Okay, for what purpose it is going to have the non-initial refundable investment? For the process. For the process, that means how to build that particular ASIC. I have to make the design of that one, and I should know that what are the different technology I'm going to make use from that one, so that I should know, and what are the different configuration I'm going to have for that particular application specific integrated circuit. What type of microcontroller I have to use, what type of microprocessor I have to use, what is the external hardware I have to component I have to uh, fix in. So those things I have to take care of. So this is nothing but non-refundable initial investment, or in your normal technology, it is called as non-recurring charges, which you're going to have. Now, sometimes what will happen, you will be having a brain, but you don't have the money to invest on research. So what that time you have to do? So I have to get help from some other person, right? So when you want to get the help from some other person, what you are going to have? So that the person who is going to invest for you will become the third party. The person who is going to invest for you will become the third party. Now, when the third party is involved in research of yours, okay, so whatever the non-recurring, that is a first-time investment which you are going to have, the first-time investment which you are going to have, if it is borne by the third party, and the application-specific integrated circuit, what you are going to develop, okay. So when it is made openly available in the market, so once it is designed, some other X person is going to fund you to do the research, and he is going to get the output. Now, what that when it is available in the market, so once all the research has been gone through, and it is made available in the market, then that particular type of application specific integrated circuit are called as application specific standard product. When it is called as application specific standard product, if the non-recurring charges are incurred by the third party, if the non-recurring charges are incurred by the third party, then that particular type of application specific integrated circuit is called as application specific standard product. Okay, so then that is called as application specific standard product. Now, once you have that particular product, yes, ma'am. Repeat. Okay. Now, when you are going to have the non-recurring charges, for example, if I want to build the application specific integrated circuit, when I'm building the application specific integrated circuit, what will happen? I may not have the money because I am building that particular application specific to that particular application for the first time. But I have the idea, but I don't have the money to build that one. Now, if I want to, I have to lend the money, but I cannot afford that one because I don't know that particular product is going to be hit in the future or not. Now, if I have that particular condition, what you are going to have? So when you are going to have that particular condition, I will take support from other third party. So the third party is going to invest the money for you to do the research. Okay. So that particular part, when he is investing the money for you to do the research and to get the product to the market, to market it. Okay. So till it openly available in the market. So then that type of application specific integrated circuit is called as application specific standard product, that is ASSP. Okay, so when it is called as ASSP is called application specific standard product. You are going to call it by when the third party is uh, donating or is investing the money on your research. Okay, when the third party is involved in uh, investing the money on your research, then that particular type of product is called as application specific standard product. Okay, so now when you are going to have the ASSP, that is application specific standard product, so it is basically marketed by multiple customers, just as the general purpose product. Okay, but to a smaller number of customers, since it is for a specific application. As I told you that whenever we are going to have the build the ASIC, that is application specific integrated circuit. So what are you going to have? So it will be used only for certain applications. So it won't be in mass. So it won't be like mobile devices. Mobile devices will be used by many people, but it will not coming under ASIC. So when it comes to the application specific integrated circuit, that particular integrated circuit will be designed and manufactured only for specific purpose. Now, when you are going to have that particular type of product, so then when it is marketed to a multiple customers, just as a normal general purpose microprocessor, okay. So how many customers will be there? There will be only small number of customers. Why you are going to have the small number of customer? Since you have designed that particular ASSP for a certain application. Since you have designed that one for a certain application, so that particular product can be sold to a minimum number of customers. That's it. So now, whenever you are going to have the ASICs, so what are they are proprietary product? That means what? If you are proprietary means what? So if X person is inventing and if he is building that particular circuit, he owns all the rights for that particular product. He owns all the rights for that particular product. So now, whatever he is going to develop, okay, whatever the IC you are going to manufacture and what are the things you are going to design that particular application should be. So you are not going to reveal that to the outside world. That will be known to you only. The person who is going to develop that particular ASIC, he will be knowing that particular product's internal working, how it works, and how it is, what are the different features you are going to have. So you can see that here as a typical example. So it is a typical mixed signal ASIC. So what it is going to have, you can see that it is going to have the IO circuitry will be there, and analog part will be there, like transistor, capacitor, um, your inductors will be there, and the digital part will be there, which will be converting your digital to analog. So then EEPROM will be there, electrically erasable, programmable read-only memory. That means that you are designed that particular IC for specific purpose. Okay, so when it is designed, some memory should be there uh, inside to hold that particular program, right? So for that particular purpose, they are going to use the EEPROM in this particular ASIC. So it is not mandatory that you have to make use of the EEPROM only. Why they are going to make use of the EEPROM only means if you want to modify the applications in the future. So then if I'm going with the ROM one-time programmable read-only memory, what will happen? Again I have to buy a new ROM and I have to again build that and I have to port that particular application into that particular hardware. So that's where you are going to lose the money. So if you are using the EEPROM, what will happen? So by providing the electricity, you are going to remove the data which is there in the read-only memory. Then you can insert another part of the code. So that you have been gone through, I think, in your computer organization when you studied about the memories. So the same thing where also. The next topic which you are going to have is programmable logic device. So anybody having any doubt with respect to ASIC? That is application specific integrated circuit. So that particular IC is designed to perform the specific application. That's it. So now, programmable logic device, all of you are remembering now? All of you
Yes, sir.
remembered where you have learned this one.
TL, PLA,
Yeah,
AD, sir.
yeah, ADA. The same thing comes here also. That is PAL, PLA, PLA, PAL, and program. So the same part here also, but we are discussing with respect to the functionality. That's it, nothing else. So if you have understood there completely, then here you don't have to worry about that one. So just read it. You will understand everything. So if you have gone through perfectly in your ADE part. Okay. So now if you take the logic devices, the programmable logic devices. So what it is going to provide? So it is going to basically provide specific functions as follows. So what are the different functionalities it is going to follow? So where it is being used? So basically it is will be used in device to device interfacing. Okay, device to device interfacing it will be used. Data communication it has been used. Signal processing it is going to be used, and data display, timing and control operations it is going to be used. So your logic devices are going to provide this functionality and it is going to be used in this field. So there you have learned how to build the programmable logic device. Here you are going to learn how it will be used in specific applications. Okay. So when it comes with respect to the logic devices, so the logic devices can be classified into two broad categories. One is fixed, other is programmable. Okay. So now So since we are going to have the fixed, so can you tell what is the fixed logic programmable logic devices you have gone through? So which are the so now the circuits is a fixed logic device or permanent. Okay, whatever the circuits you are going to have, it will be having fixed logic device or permanent. So they when they are going to have the fixed logic, so it is going to perform only one function or set of functions once manufactured, and they cannot be changed. Okay, so they cannot be changed once you are going to have that particular set of function, and they cannot be changed what you are going to have once it is programmed. So there we have come to programmed. So that means with the and or array, you are going to have the sum of the functions, right? We are going to build the functions with some set of arrays. So when you are going to have some set of arrays and you are going to build some logic function, depending upon the type of the work, what that particular application has to do. So like that, you have to program it. Okay, that's what it is going to have. So your programmable logic device, what it offers to the customer. So basically your programmable logic device, it offers a customer's a wide range of logic capacity. So it's going to offer a wide range of logic capacity, features, speed, and voltage characteristics. And whatever the device you are going to have, that will be reconfigured to perform any number of functions at any time. So whatever the logic devices you are going to have, so that can be reconfigured. Reconfigured means what? You can, if you are going with the EEPROM, so again I can reset it and I can design a different specific functions. So there we are using the PLA for having the Boolean function, right? So Boolean function is nothing but what? So whatever the output you require, that you want to build it. So the same thing will be used for this particular type of applications where you are going to make use of. So now in this one, what will happen? A designer who is going to have, they are going to make use of the inexpensive software tools. Okay. So because we have to burn the AND array and OR array. So sometimes it will be where AND will be fixed or will be programmed, and in some of them it will be AND will be programmed or will be fixed. And in your PLA, both your and OR is fixed. So in programmable AND array, what is fixed? Your AND is programmable and your OR is fixed. Okay, so that's what you are going to return. So when you talk about the programmable logic device, so they are basically based on rewritable memory technology. So they are going to make use of the rewritable memory technology. So now whenever you are going to have the rewritable memory technology, what it indicates? So whenever you have to change the functionality of that particular PLD, so it can be reprogrammed. So if it is based on rewritable memory, so rewritable memory means what? So now if I'm going to change the design of that particular PLD, so depending upon the requirement of the functionality, so I'm going to reprogram it. I'm going to reprogram the change of the to change the design. That's what we are going to have. So now if you take the two types of programmable logic devices which you are going to have, we are going to have complex programmable logic devices. Second is pre-programmable gate arrays. So this is built on top of your three PLDs which you have been studied. That is your PAL, PLA, and programmable data PROM. Okay. So now in your field programmable gate arrays, so here your field programmable gate array is nothing but an IC. So it is going to have more number of PLDs inside. So if you when you start talking about the PLD, so one such a specific function you have been designed, and for but that particular design you have been built the PLD. But when you are going to have the logic function or some application you want to fit, there you require multiple amount of PLDs, right, inside a single IC. So when you want to have the multiple PLDs inside a single IC, we have to go for a complex programmable logic devices where multiple PLDs will be there inside a single IC. Where multiple PLDs will be there inside a single IC. So that depends upon that how we are going to program it So that how we are going to reconfigure it, or how we are going to reprogram it, that depends upon the two types of programmable logic devices. So those two types of programmable logic devices which you are going to have is, one is complex programmable logic devices, other is free programmable gate arrays. So if you start discussing about free programmable gate arrays, so it is an IC. Okay, your FPGA is an IC. So what it is going to have? So it is going to be designed to configure by a designer after manufacturing. So IC designed to be configured by the designer after manufacturing. So that means what? So you are going to design the IC. So and then after designing the IC, I am going to configure that particular IC depending upon my requirement. Because initially how many logic functions should be there, how many gates should be there inside that particular IC, they will manufacture it, but they will not program it. Okay. So once it is designed and it came to the market, so it is up to the developer. What are the different functionalities he has to provide to that particular IC? So that when you are programming after designing it, okay, so after designing it, then that particular type of logic devices are called as field programmable gate arrays. So these IC are designed to be configured by a designer only after manufacturing. That means what? That particular FPGA will be manufactured. So they are going to give you that certain PLDs where it may be having the 100 PLDs or 150 PLDs depending upon the manufacturer. Okay, that you have to refer to the manual of that particular manufacturer of that particular IC. So when you take that particular IC manufacturer's manual and you read it, you come to know that what are the facilities which is provided for that particular FPGA. Because there will be number of vendors will be there for FPGA. Many different vendors will provide you different functionality. It is like similar to the when you go to the market, if you buy a product, the same product will be there for 10 rupees also, the same product will be there for 20 rupees also, the same product will be there for 100 rupees also. Why it will be different? It will be different depending upon the functionality what they are going to provide. Some may be giving the additional functionality, some may be giving the limited functionalities. So when you are getting the limited functionality, obviously the cost which you are going to incur will be less. So now when you are going to have the FPGAs, the FPGAs is normally going to offer you the high code density. Okay, it is going to have the high amount of logic density. The most features, since it is going to have the high code density or high logic density, so it is going to have the high performance. So the high code density or high logic density means what? It is going to have the more number of logic gates, more number of PLDs inside that one. If you have the more number of PLDs, in turn it is going to have, you can build the more number of logic function, right? More PLDs, more logic function. If you have the more logic function, the performance is more. That is going to have the highest performance. Okay. So even the logic gate you are going to have in that particular FPGA is medium to high density. Okay. So the logic gates which you are going to have, you are going to have in that particular FPGA, it will be in from medium to high density range. That is from, it may be from 1000 to 5000 system gates. So you can see it here, how many gates will be there. So it may be from 1000 to 500,000. That is nothing but your 500,000 is 5 lakh. Up to 5 lakh system gates may be there inside your field programmer gate array. So this is how it will be there. Okay. So your FPGA device is offers features such as built-in hardware processors, such as IBM PowerPC. That means if your IBM PowerPC is one of the example of your FPGA. So that's why it is referred as that example they have taken. So when you have taken the FPGA, the example what they are going to take is IBM PowerPC. So in that particular in that particular FPGA, what it is going to have? So it's going to have the substantial amount of memory. So you are going to have the memory where you can store the data. So that means depending upon the programming, right? So memory is nothing but what you are going to program it. After programming it for a designed logic function, so you are going to build that particular logic function, right? Or that you have been studied in your basics of your ADE. So now the next it is going to have, it should have the clock management function. Okay, so to clock management function should be there to have the performance. So how fast the logic function has to shift from one logic function to the other shift, and support for many of the latest. Okay, so it may be giving very fast device to device signaling technologies. That means you are going to have the n number of flash memory. You can see it here, IOB. So all these are memories only, which you are going to have. Okay. So basically for FPGA are basically used in high variety of applications. So it is going to be ranging from data processing and storage to instrumentation, telecommunication, and digital signal processing. So these are the places where you are so these are the some of the applications where you are going to make use of your FPGA. So next is CPLD, that is complex programmable logic devices. So you can see it here, as the name indicates, complex programmable logic devices. It's a programmable logic device which complexity lies between a PALS and FPGA. PAL is programmable array logic and FPGA is field programmable gate array. So programmable logic is nothing but programmable array logic is nothing but what? What will be programmed at the input side and the output side to build your functions? Can anyone
And
answer?
this program.
Both your and or are programmed, right? In PAL, programmed array logic. Okay. And is
Sir, that is in PLA, no, sir.
PLA. So here it is and is programmed or is fixed.
Fixed.
Okay. So here when you are going to have the programmable logic device, so here the complexity lies between PALs and FPGAs. Okay. So the complexity which you are going to have, that will be lying between programmable array logics and field programmable gate arrays. Now, if we take the CPLDs, that is complex programmable logic devices, it offers smaller amount of logic. Okay, so compared to your field programmable gate arrays. So in the field programmable gate arrays, depending upon the manufacturer, the number of gates which will be there, it will be having is around 1000 to 5 lakh. But here in your CPLD, compared to your FPGA, so it is going to offer only a small amount of logic. So the small amount of logic which you are going to have is here is 1000 gates. So why we require gates? So gates you require to build some applications, right? So you require what are the gates you require? One is OR gate you require, other is the AND gates. So the number of OR gates and number of AND gates which you are going to have when you are building your CPLDs is around 10,000 gates. So whenever you are going to come across your programmable logic device, what are the two gates which will be involved? What are the gates which will be involved there? What are the gates it is going to involve? And or and whether it includes not. So even the NOT gate is involved there, right? So if you want to generate the complementary, if you are going to have the A bar, if you want to generate, you should have the NOT gate also there. So that is what they are going to specify with respect to the gates. So when you are talking about the CPLDs, by contrast, offer much smaller amounts of logic, up to 10,000 gates. So that's why you should have the proper basics in your ADA. Because if you are not studied ADA, then it will become difficult for you to understand here. So since you have been studied ADE properly and you know how the PLD works and the your programmable logic device works and what are the gates involved in your programmable logic device, then it will become easy for you to understand here. Because we are telling that it includes only small amount of logic. So small amount of logic, it may be include up to 10,000 gates. So what are the different gates? You will understand that gates which will be involved to build a specific logic function is and or and not. So those gates will be around only 10,000 gates, which will be having. So if you are going to have the 10,000 gates, only minimum amount of logic function compared to the FPGA you can build. But in the FPGA, the maximum gate is what? 5 lakh. So if you have the 5 lakh gates, obviously the more logic functions can be built, you generated. If you are generating the more logic function, what in turn it is going to tell that it is going to have the more performance compared to your CPLD. So now, if you take that complex programmable logic devices, it basically offers very predictable timing characteristics. Okay, so your CPLDs offer very predictable timing characteristics. Yeah. So it is going to have the very predictable timing characteristics, and therefore it will be ideal for critical control functions. Okay, so therefore it will be ideal for critical control functions. So now if you take the CPLDs, so CPLDs such as the Xilinx co-learner series also require extremely low amount of power. Okay, so the another support of the example of your CPLD is Xilinx co-learner series. So what that particular series requires is it requires extremely low amount of power. Okay, since it is low, since it requires lower amount of power, obviously the power consumption will be less and it will be inexpensive. And when we are going to have these particular features, where I can make use of, so I can make use of this particular IC where it is cost sensitive, where I have to build the application with less cost and which will be battery operated, since the amount of power which is going to be consumed is less. So if the power consumed is less, obviously I can run in a battery. So you can use this particular type of CPLDs where it is ideal for cost sensitive battery operated portal applications. So that is nothing but where you are going to make use of these CPLDs in mobile phones and PDS, that is digital handheld assistance. So the other name for your digital handheld assistance is PDA, that is personal digital assistant. Okay, the day is the same name. Digital handheld assistant is called as personal digital assistant. Okay, so these are some of the CPLs. This is what the this look like. So you can see it at PIL like block. So how many blocks are there? 1, 2, 3, 4. This is simple structure they are giving. It is not that only 4 will be there, because depending upon the number of gates, more number of PL like block may be there. Because if you want to generate more number of logic functions, the more number of PL you should have. So all of you understanding, right? What do you mean by this PL like block? What do you mean by PL like block? What it is going to generate? What do you mean by PAL? Programmable array logic, right?
Programmable logic.
What it is going to provide? It is going to provide the logic function, right? So each individual block is going to provide you the different logic function. Okay, because you have to program it, right? So you have to programming the AND array, and you are going to have the fixed OR array, right? So now when you are going to have, by programming the AND array, so you are going to generate one function, logic function. So similarly, different PAL like blocks will be having different logic function. Okay, when you are generating the different logic function, when you want to work or when you want to program it, and we have to work on certain applications, all these are interconnected together. All these logic functions are interconnected together, and it will be performing some operation with the input output block. So when it is where the input output block, you are going to make use to communicate with the outside world. That is when you are making the communication with the microprocessor, which will be used in your embedded system. Okay, so now you will understand that why you need to study ADE, because ADE is you have to study when you want to build a uh, good embedded system. Okay, so when you want to build a complex embedded system, so you should have some basic knowledge of ADE. So why that is taught in your third semester for this one. So you should have to have the knowledge of embedded system. You should have the knowledge of your ADE and computer organization. So if you have the knowledge of computer organization and ADE, then the concepts which you are going to study in your embedded system will become easier. Okay, so that's how the subjects will be put in your curriculum. So next, when it comes to the advantages of programmable logic devices, so since this is already you are known in your from your third semester itself, it offers customer much more flexibility during design cycle. So how we are going to justify this particular term? So since the PIDs offers customer much more flexibility during design cycle itself, means what? Because the customer, the developers will be knowing that what function I have to generate, and depending upon the functionality, what he is going to generate. So at the time of the design itself, you come to know. Okay, so that's what it is going to have. So now when you are going to have the PLDs. So these PLDs do not require the long time for lead time for prototype or production. So since it is already on the distributed shelf and ready for shipment. So now, since already it is available, so only depending upon the functionality what you require, so you have to design for that particular functionality or program it for that particular functionality. So since the programming depending upon the application, it won't require that much time to make. Okay, so when you are going to have less time to make to program, so obviously it will make a little time to generate the prototype. Okay, and always it will be available for the distribution. So it is not require customers, do not require customers to pay for large non-recurring cost. Okay, what do you mean by that one? So because since it is available on the shelf, okay, so that means whenever I require that one, it is I will program it and I will ship it. That's it. Okay, at that time what will happen? So the non-recurring cost or research cost which you are going to have, that won't be incurred more. The non-recurring charges will not be incurred more. That is the first time investment. Non-recurring charges is nothing but what? It's a first time investment which you are going to invest when you are developing some product. So now everything has to be paid by the customer only. How you can know? So you just take an TV, one TV if you're coming for the market for the first time, for example. So obviously the product of the price of that particular TV will be more. Why? Because when it initially comes, I don't know that whether that particular product is going to be hit or not. Even that product may not sell in the market. So what I need to have that time, initially I should make my profit or whatever the investment I have done for my product, that has to be that I have to get back. So when you are going to have the develop that particular product in such a way that what you are going to have or what you are going to do, I will make my product cost to be go more. So I will put more cost on the product which I'm going to sell. That is the reason when it comes to the market, what are the costs it is incurred? It includes the cost, it includes the research cost, what has been happened for that particular building the product, okay, and how much money it has been invested on that particular product. All these costs will be incurred on the customer only. Now, once that product becomes more and more familiar, what will happen? They started on reducing that particular product. Okay. So now our human tendency is what? Whenever a new product comes, if the feature is good, we will buy it once in the beginning only. So that is not the strategy which you need to go. Because initially when it comes to the market, always that particular product will cost more because they have the non-recurring expenditure also incurred in that particular product. That means when they are building for the first time, they would have done the research. To do the research, many components has been harmed because I don't know in the first attempt only I'm going to get the output. So if you want to get the output, I have to make the multiple experiments I have to do. When you are doing the multiple experiments, you may lose some of the components or you may lose some of the money. So even the loss, what you have been happened when you are developing that particular product, that also be incurred on the customer only. Okay. So that is required. That is what you are. That first, it is going to tell you that here that particular scenario will not come. So it is already available. Depending upon the logic function, I am going to reprogram my PLDs. So for that particular reason, so your customers need not have to pay the much of the non-recurring charges. Okay, non-recurring cost and purchase expensive mark set here. So your PLDs, what it is going to allow, it also allows customer to order just the number of parts required when they need them. So what the customers is made to allow only the parts required for that one and allowing them to control inventory. So as we have seen that your PLDs are reprogrammable even after the piece of equipment is shipped to the customer. As I told you that even if it is programmed and if you are shipped that particular customer, if any changes is required by the customer, so they can request you and you can reprogram it depending upon the type of the PLDs which you are using. Okay. So that is what your PLDs is all about. So any doubt, anybody having any doubt with respect to the PLDs, programmable logic device, if anybody is having any doubt, FPGA, PLDs, the complex programmable logic array. So how many gates will be there in your feed programmable gate array? How many gates?
3 gates.
3 gates, but inside 3 gates will be there. That is minor logic gates. That is and or and not. But inside a single IC, if we take the FPGA, how many gates will be there? It will be from which? What is the range of number of gates which will be there inside a single IC? That is 1,000 to 5 lakh. When it comes to the complex programmable arrays, it will be up to 10,000 gates which will be there. They will tell in generally that 10,000 gates are there. That what are the gates which are there is and or and not. So those gates are required to generate the Boolean function. Okay. So that is what your PLDs stands for. So next we are going with the commercial off-the-shelf component. So in the next class, I am going with this particular topic. So if you have any doubt with respect to previous classes, you can ask. If you have any doubt, because this particular topic is vast. So all of you have gone through the memories, right? I want the answer from your side. All of you have gone through the memories, right? All of you have gone through PROM, I think, in your computer organization. Yes or no? That's it. Nothing else. Don't wait to answer.
Yes.
Memories you have read, right? Memories is there as part of this particular syllabus also. So shall I skip or just I want to brush it up? I want the answer from your side because that particular part is also very vast. So whether I have to touch or whether you will read by yourself, that is the second question which I require. LED you have read, right? Working of LED you have read. Have you
Yes.
read or not? Working of LED you have read. Working of octocoupler also you have read, I think, right? Octocouplers, all of you, can you people remember? What do you mean by octocoupler? What do you mean by octocoupler? Shall anyone remember? Huh?
Combination of LED and
Yeah,
layers.
yeah. So it is your optocoupler is also a part of your embedded device. Okay, here. So yeah, that part also you read it by yourself because I'm not going to cover it because this particular module is too vast. Okay. So if I'm going component one, I cannot complete this one syllabus within your time frame. So just I will just brush it up. I will revise and I will give you the overview of that particular subject. That's it, nothing else. Okay. So just I will brush it up. So that will be as part of your syllabus here. So apart from which you have been done, so I think you have been gone through this flash. You have gone through, right, in the memory. Flash have you gone through? Yes or no? That's it. Yes means yes. No means no. To tell yes or no. NVRAM you have gone through. NVRAM.
No, sir.
Okay. PROM have you gone through? PROM.
Yes.
Masked
Yes.
ROM. Masked ROM.
No, sir.
Masked ROM you have not gone. EEPROM.
Yes.
EEPROM. Okay.
Yes, sir.
Maybe flash have you gone, right? Flash have you gone or not?
No, sir.
So I think flash, NVRAM, and masked ROM you have not gone through, I think, right? In this one.
Yes.
So
Yes.
remaining PROM, EEPROM, and EEPROM we have gone through. So just I will skip these three. Okay. I will skip flash, EEPROM, and EEPROM. I will do only NVRAM, masked ROM, and flash. Okay. So remaining memory you read by yourself. So since it will consume more time, so I don't want to waste time for that one. So once it is done, should have send actuators. So 778 display, can you remember the code what I have explained in the ADE class? Can anyone remember now?
Yes. Yes, sir.
Shall I skip that part also?
Okay, sir.
Okay, so the same part, the same thing what I have been explained in the ADA, the same concept here also, the same thing. You can after couple of hours I will skip. Okay, so I will start. Stepper motor I have explained in there.
No, sir. No.
Okay,
No, sir.
okay. We'll go with the stepper motor. So some part of the memory I will leave so that you have to read by yourself. So when it comes to the sensors and actuators, you have to read LED and optocouplers by yourself. Okay. So just read it by yourself, some part, so that I can complete this particular module fast. Because after this particular third module, part of your fourth module I have to touch to give the questions for your IA. So I have to complete by next Tuesday only this particular unit. So this is vast. So just have to complete it faster. Okay, if you have any doubt, you can ask.
Sir, regarding quiz, sir.
Ah, yeah, it's over,
Third
right?
question is
Third question, it's wrong.